In this video, we're going to look over an example problem on page 436 of your textbooks, number 68. Butanoic acid has an acrid taste and an unpleasant odor. It's found in rancid butter and Parmesan cheese. In aqueous solution, butanoic acid undergoes the following reversible reaction, and I have that written up right here. A, what substances are present in equilibrium? Well, what do we know about equilibrium? Equilibrium is when the reactants and the products are in the concentrations and don't change. Okay, they reach the kind of the concentrations that are dictated by the dissociation constant of the acid, and they react to a certain degree and then finish. They don't react anymore. Or they have a dynamic equilibrium while they're reacting, but the concentrations don't change at all. So part A, all four of them. All four are going to be present here: butanoic acid, water, butonate, and hydronium. This is a weak acid. Obviously, it has to react some water to form butonate and the hydronium ion. So some will be produced, but you're still going to have water, you're still going to have hydronium and the butanoic acid and its conjugate base, which is butonate. B, at equilibrium, are reactants or products favored and why? Well, this is a weak acid. Here's the hint. It's a weak acid. So that means it's not pushing very far to the right. So reactants will be favored. C, is the concentration of butanoic acid and butonate ion constant or changing at equilibrium? At equilibrium, there's no net change. Remember? No net change. So the answer is no, they're not changing. And finally, part D, what is the significance of the two opposing arrows in the equation? Oh no, there's an E. So D, what is it? We're talking about a reversible reaction. Reversible reaction. And finally, E, label the conjugate acid-base pairs. Okay, very good. Well, butanoic acid obviously must be an acid. Let me change colors here so we can actually see it. So this is going to be the acid. And that means water here is acting as a base. So the conjugate base of butanoic acid is going to be butonate. We see that negative sign there. So this is going to be the conjugate base of butanoic acid, and all right, so that's going to be the conjugate base, and the conjugate acid of water as a base, and I don't have much space, so I'll just do conjugate acid as Ca, okay, of water. And there you go. There are the answers to that question, and hopefully you can follow through on the others like it.